Okay, so this is still notes 1-4, but number 4 is different than what we had on the last recording. So on number 4, we have log of x. Notice there's not a base, it's missing. Anytime you have a log that's missing a base, that is called a common log, and the base equals 10. So even though it's not written there, you have to know that that base is 10. So if that base is 10, your base of your exponential would be 10 to the x. On this, you can actually type in the common log because base is 10. So you can either type that one in or type in the exponential one. I would say the exponential one would probably be easier, but if you wanted to do log, it's right below x squared, log. So you would type log of x, and then you can go to your table. But I'm going to go ahead and type in the exponential first. So 10 to the x power. Go to my table. I'm going to go from -3 to 1. -3 is 0.001, -2 is 0.01, -1 is 0.1, 0 is 1, and 1 is 10. Okay? So in order to find the other one, then all you would have to do is switch your x and y. So on your log one, it would be 0.001, -3, 0.01, -2, 0.1, -1, 1, 0, and 10, 1. Okay, so let's start out with graphing our log, which is our relation, the original. So it's 0.001, -3, and then 0.01, -2, and then 0.1, -1, 1, 0, and 10, 1. So notice that it's approaching the y-axis here. So anytime you have a log, it will be approaching a vertical line, which in this case it's the y-axis. I'm going to label that as the original f of x function. And then I'm going to graph my y equals x line. And then I'm going to graph the exponential graph. So -3 would be 0.001, -2, 0.01, -1.1, 0, 1, and 1, 10. So it's approaching the x-axis. So anytime you have a exponential graph, that's the inverse, it will be approaching that horizontal line. So in this case, it's the x-axis. All right, your domain and range are the same every time for your log and your exponential. So I'm going to go ahead and skip over that and then go on to number 5. Number 5, you have an ln. That is also a log. Anytime you have just an ln, that will represent a natural log. And that base, it's not written, so that base is an e. E is a number, okay, so it's a variable that represents a number, okay, so just like pi represents 3.14. E, if you look at your calculator, there is an E on your calculator. Second, divide, if you press enter, and it shows you what E equals. So E is just, it represents a number, okay? Alright, so if the base of our natural log is E, that means the base of our exponential will be E to the x. Again, you can either type in the log one or the exponential one on this one, because you can type in a natural log. Okay, that button, if you wanted to use that one, is second, actually not second, just ln, which is right below the log button, and then you would type in x. Okay, so you can type that one in, or you can type in the exponential. It doesn't really matter. Since we've been doing the exponential, let's just start with that one. So there is an e to the x power, which means you just raise it to any power that you want. So that button is second and then ln. So that's e to any power. We want it to be to the x power. And then you can graph it to see what it looks like. Notice that it looks like an exponential graph. It's approaching the x-axis. So if I go to that table, let's go from -2 to 2. So that would be -2.1, we'll round to 4 decimal places, or 2 decimal places, so that would be 0.14. -1 would be 0.3701, 1, 2.72, and 2, 7.39. To find the natural log of x, you can just flip those points. So that would be 0.14, -2, 0.37, -1, 1, 0, 2.721, 7.392. Now, depending on whichever one you choose to graph first on the calculator, you might get different numbers, but the graph should look the same. Okay? Because if we had typed in the exponential first, we ended up with these whole numbers in the x. But when you flip them, you don't get whole numbers over here on this other one. So if you had plugged in the natural log of x first, you wouldn't have had these x values in that table besides 1, because those are decimals. So even though if you did the natural log first, when you graph it, it's still going to look like the same graph. Okay, it just might not be the same points. Alright, so I'm going to graph the natural log of x first. So 0.14, -2, 0.37, -1, 1, 0, 2.721, and 7.392. So it's still approaching the y-axis. That's the original. If you draw your y equals x line, it should be a reflection across that. And then the other one, we have -2.14, -1.37, 0, 1, 1, 2.72, 2, 7.39. So it's also approaching the x-axis, so every exponential will do that on this lesson. Alright, again, domain and range is the same. Okay?